Hey guys, I'm going to go over Chapter 8, Section 4, Proportionality Theorems. There's 4 of them. These 3 are super similar, not crazy. This one's a little bit different, so that one's a little harder, okay? I'll go through them. I'm not going to explain the whys, I'm just going to do them, okay? So on this picture, what I want you to see is that you have a triangle, and I drew a line parallel to one side of the triangle. I could draw the triangle and do this with any sides. So I could have the triangle this way and draw a line parallel to this side, okay? Or I could draw the triangle, let's do this one, and I'm going to go parallel to this side, okay? It doesn't have to be through the center. It only, like the midpoint of both sides, that doesn't have to happen. But the line that I draw has to intersect 2 sides and be parallel to one side of the triangle. That's it. So, if a line is parallel to a side of a triangle, that's the first part. It has to be parallel to one side of the triangle. It does not matter which side. Remember, these symbols mean parallel, okay? It has to be parallel to one side, and it has to intersect the other 2 sides, and intersects the other 2 sides, okay? If that happens, then, okay, this is my if. If this is true, then what it's going to do, like everything we're doing, we're dividing these 2 sides proportionally. This side proportionally with this side. So we're going to, this A is to B, a C is to D. As long as this is parallel, this will be true. Okay? If the line's parallel, then A will be to B as C is to D. We could draw it the other way. A is to C as B is to D. Remember, it's a proportion, okay? Then the line divides the 2 sides proportionally, which means the 2 ratios are equal. And then you can do all the cool stuff, okay? So for example, this side is parallel to, this line is parallel to my side, and I say this is 2, this is 3, right? This is 4, what's that length? So I'm going to go 2 over 3 equals 4 over x, right? Do cross products, or you guys that are good at math, you can see what to do. 2x equals 12, divide by 2, x equals 6. Okay, so all we're doing is proportional. This one's the converse of this. So in this one, we're going to say if the sides are divided proportionally, then the 2 lines are parallel. Okay? You get what we're saying? If a line divides the 2 sides proportionally, then these 2 lines are parallel. So we're going to do this. Okay? If a line divides 2 sides of a triangle proportionally, the 2 ratios are equal. Okay, then the 2 lines are parallel. Okay, or we should say it's parallel to the 3rd side. This is lazy. I'm going to do lazy. I'm going to finish it. The 2 lines are parallel. The better way to say is the line is parallel to the 3rd side. Okay, that's it. This is better. This is okay. Okay, this is better. The line is parallel to the third side. Better words. So if I could show you these ratios are equal, so if A is to B as C is to D, right, we're switching it. If A over B equals C over D, then I would go ahead and say this line is parallel to this line. Okay? Okay. This theorem is very similar. Again, I'm not proving it. I'm just telling you. Okay? But we got to review for a quick, just real quick. Okay? If you go back and you have parallel lines, and it could just be two lines. They don't have to necessarily be parallel. And then the third line that cuts across, trans is to go across, like translate, you're going between two languages. Transport, you're carrying between two different places. Trans is to go across. So this is a transversal. The transversal intersects two lines at two different places. This one's a transversal. These are the two lines that we would always, these are your parallel lines. If I put arrows here to indicate parallel lines. Okay, I'm just reminding you of what transversal means. Okay, so I've got three lines that are parallel. They do not have to be spaced evenly, okay, but they have to be parallel. And I have two transversals. Here's transversal 1, here's transversal 2. Transversal 1, line L, transversal 2, line M. So in this case, I've got three parallel lines, and they're intersecting two transversals, okay? I'm just describing the situation. If three parallel lines intersect, okay, two transversals, okay? Then what's going to happen is the same thing we've been doing all chapter long, okay? We are going to divide, I'm trying to find color. We're going to divide the two, this transversal and this transversal, proportionally. So like here, A, this distance, B, okay? C, this distance, and D, okay? So if they're parallel, we intersect two transversals, then A is to B, A divided by B equals C divided by D. Okay? That's all we're doing. Okay? Then the parallel lines divide the transversals proportionally. Right? Into equal ratios. Into equal ratios. Okay. As long as they're parallel, then A is to B as C is to D. Okay. Last one. Now this one's a little bit harder. Okay. So let's talk a couple things. Okay. Let's talk about bisect. Bisect means to divide into two congruent parts. So if I'm bisecting a segment, okay, if I bisect a segment, that means this length is congruent to this length. That's what bisect does. If I bisect an angle, which is what we're going to do, okay, I'm bisecting means I'm dividing it into two congruent angles. Those arcs are saying these two rays are opened the same amount as these two rays. This angle and this angle are equal because we're bisecting the angle. Okay, so let's say this. If a ray bisects an angle of a triangle, okay? So look what I'm doing. I've got this ray right here. This is a ray coming out. This is a ray. Endpoint goes in one direction. Endpoint goes in one direction. I am bisecting angle C into two congruent angles. Bisect divides it into two congruent angles. So I have to see this in a picture. If I see this, then, okay, the ray divides the opposite side. Okay, I'm dividing. This is my opposite side right here, right? This ray's shooting out, and you can see it's dividing segment AB, okay? Now, it does not mean it's dividing it in the middle. It does not bisect it. It could, but not necessarily. But I'm dividing it into segments that are proportional, okay, to the other two sides, to the other two sides of the triangle. Okay? So this length here, from A to D, I'll call that A, and D to B, I'm going to call that B. Okay? A over B, okay, is equal to this length, the other two sides, C over D. Okay, I'm going to do it the long way too. I'm trying to do this just so you could see it. A is to B, SC is to D. I'm going to use the letter so I do better. A segment AD over segment DB. Okay, the length of AD over the length of DB equals the length of, oh goodness, I can't see it, CA over the length of CB. I'm using the capital letters here. Here I'm just shortcutting with lowercase letters. Okay, I'll do a couple problems with you, that's all. I'm not going to do the whole thing. This one says find length AB. So I'm going to put X here. This is what I'm finding from A to B. Because this side, this line is parallel to that side, I know these two other sides of the triangle are divided proportionally. So X is to 3 as 12 is to 4. And you guys can look at this. 4 times 3 is 12, so I got to go times 3. But do your cross products, however you need to do, find it. Okay, this one, what's the length from A to B? A to B, okay? So I'll call that one X. I'm going to do the same thing, right? That's what I have to find. 14 is to 12. If you want to reduce it and say 7 to 6, you can. Makes the work easier. X to 18. Okay? Solve it. Cross products, right? Okay, this one. Okay, this one does not tell me that line YZ is parallel to line YX is parallel to line UV. It does not explicitly tell me that, but it tells me that this transversal intersects these three lines at right angles. Because these are all corresponding angles, that means the lines are parallel. Okay, so I know all three of these are parallel because of the right angle symbols. If they're all intersecting at right angles, they have to be parallel. Okay, so then this one says find length from V to X. V is this intersection, X is this, so I'm finding this right here. There's my X. That's what I'm trying to find. So I'm going X is to 15 as 8 is to 20. And you could have gone in different order, right? You could have gone 15 over X, 20 over 8. But the key thing, remember, is always to check, is your cross product the same as mine? Is 20x equal 15 times 8? Is that your second line? Okay? This one is my third one. This one's the one that's different. So on this, really, you can erase the picture and just draw the ratio, or write the ratio. if I'm dividing, right, and bisected the angle, so I'm dividing this side, so it's proportional to this side. You have several ways you could write this. 4 is to 6, as 8 is to y, right? You could go 8 is to 4, as y is to 6. Can you guys see? Remember, the key thing when I grade these, do we have the same cross products? Because it's a proportion, we can write them different ways. The key is, do I get 4y equals 48? Okay? This one, same. Okay. Let's see if there's anything different on them. Okay, I want to do this one. This one's hard. Find the length of R to S. It tells me this whole length is 15. So I got to call this length something to write my proportion. My proportion is going to go this number to x equals 7 to 13, right? That's what I'm going to do. But what do I call this? Okay, let's just think for a second. This whole length is 15 long. This much of it is, let's say, 5 long. You guys would go, okay, how do I get this length? You know, I would say 10. And I'd say, how did you get 10? And you go, well, I went 15 minus 5 gave me the 10. Okay, let's change that. Instead of 10 and 5, let's say this is x. If this is x long, how long would this segment be? Just like if this were 5, this is 15 minus 5. This is 15. I use up x, so I got 15 minus x for this segment right here. This segment right there, oh my goodness, messy, is 15 minus x long. Okay, do your cross products. I think there's one more like that. But these are pretty straightforward. Use those. Good luck. Let me know if you have questions. I'll show you the congruent triangles and why that works in class. Okay, you guys have a good day.